Alright guys, looking at activity 3B.2, our learning objective is I can solve quadratic equations involving imaginary numbers by completing the square. So last video was finding these solutions by taking the square root. Now we are going to be completing the square. The good thing is that completing the square is exactly the same as what we were doing in KC2. We might just have some imaginaries or some square roots of negatives pop up, but overall the process is the same. So if I have x squared minus 8x plus 21 equals 0, our first step is to move that constant over to the other side. So I want to subtract 21 because, again, that is the opposite operation. So then I'm going to have x squared minus 8x. I know I will be completing the square, so I'm going to go ahead and leave myself that blank side. Equals negative 21, again, adding whatever that blank is. Also, one thing to remember is that we're always going to be adding that constant because, again, two negatives would multiply to give us a positive. Step 3, rewrite the perfect square trinomial. Step 2, complete the square by filling in your box. So I'm going to do the work over here on the side, actually, so we can kind of see what's being done, but I don't want to ruin the steps that I currently have going for me. So step 2, it says complete the square by filling in your box. What that means is that we have our Punnett square box, right? We have to look for our x squared, which is what we know, right? We have that minus 8x, so that is what I'm going to be dividing in half. So negative 8x divided by 2 is a negative 4x. That is what I'm going to be writing in each of these diagonals. And then I have to kind of go back and multiply and figure out how I got these. So x squared is going to be x times x. Negative 4x is going to be x times a negative 4. X times a negative 4 is going to give me a negative 4x. So therefore, a negative 4 times a negative 4 is going to be a positive 16. Again, reinforces that that constant is always going to be a positive number. That is what I'm adding on each of the sides. All right, that is step 2. Step 3 says rewrite the perfect square trinomial. So one thing to remember, if you have a highlighter or something, whatever you have here on the sides is that perfect square trinomial, okay? So when I rewrite that, all I'm going to be doing is writing x minus 4, there was 2 of them, so I'm saying quantity squared, equals the right side, negative 21 plus 16 is going to be a negative 5. So again, that x minus 4 comes from whatever we had on the side of our Punnett square. All right, so now continue on with step 4. Take the square root of both sides. So I need to solve for that x, so I'm going to take the square root. So square root, square root. This is going to be x minus 4 equals plus or minus square root of 5 times a negative 1. X minus 4 equals plus or minus. That square root of a negative 1 becomes I. There is no square root of 5, so that goes after the I. Still need to solve for my variable, so I need to get that x by itself, which means I have to subtract. I'm subtracting 4, so the opposite would be to add 4 over. My final answer then is going to be x equals 4 plus or minus I times the square root of 5. Keep in mind that plus or minus sign does give us our two solutions, right? These two solutions would be x equals 4 plus I times the square root of 5, as well as x equals 4 minus I times the square root of 5. So that plus or minus gives us our two solutions. All right, let's practice some of these more with completing the square. So again, if you ever need those steps, they are on that first example. All right, looking at example number 2 here. I have x squared plus 4x plus 13 equals 0. So the first step is move that constant over to the other side. So minus 13 minus 13. I'm going to have x squared plus 4x. I know I'm going to be adding some constant. I have that negative 13 over here, and I'm still going to be adding that constant over. So we want to be able to figure out what our what constant we're going to be adding on each side. So I'm kind of just going to do the work over here. I know I'm going to have some Punnett square. Do it over here. Some Punnett square. I'm going to have x squared here. And then I need to take that middle term and divide it by 2. So that 4x, right, it was a positive, so I'm going to divide it by 2, and I'm going to get a positive 2x on each side. So this is going to be 2x and 2x. Filling out the other sides of the Punnett square. This is going to be x times x. Why doesn't it let me click the green? X times x. This is going to be x times a positive 2. This is going to be x times a positive 2. So therefore, my constant is going to be 2 times 2, which is 4. That 4 is what I'm going to be adding on each line here. Then the next step is rewriting the perfect square trinomial. So that perfect square trinomial comes from whatever I have on the side of my Punnett square box. So this is just going to be x plus 2. There was 2 of them on each side, so I'm going to square it. Negative 13 plus 4 is a negative 9. I want to solve for x. X is being squared currently, so the opposite operation, the inverse of something squared, is take the square root. I'm going to have x plus 2 equals a plus or minus square root of 9. Negative 9 can be broken down to 9 times a negative 1. Therefore, x plus 2 is going to equal plus or minus 3i. I want to do the opposite operation, so I'm going to subtract 2 on each side. So x is going to equal negative 2 plus minus 3i. I have 2 solutions, that plus and minus sign. So my 2 solutions are 2 imaginary solutions. Why? Because they have that I in there. Looking at number 3, I have x squared plus 6x plus 18 equals 0. Again, move that constant over by subtracting it or doing the opposite. So x squared plus 6x, I'm going to be adding some constant, equals negative 18 plus that same constant on the left side. I want to complete the square on this. So x squared, top left corner, I have that positive 6x, so 6x divided by 2. We are always cutting in half, we're always dividing by 2. So 3x is what I'm going to be placing on each of those diagonals. When I figure out the outsides of the Punnett square box, x times x gives me x squared, x times a positive 3 gives me a positive 3x, x times a positive 3 gives me a positive 3x, and 3 times 3 is a positive 9. So that positive 9 is what I add on each line. And then we find the perfect square trinomial. So again, those are the sides of my Punnett square box. If you need to highlight it, go ahead. X plus 3 quantity squared is going to equal negative 18 plus 9, which is a negative 9. I'm going to take the square root of both sides because I want to get x by itself. So x plus 3 equals a plus or minus square root. I'm going to break up this negative, so 9 times a negative 1. It's going to be x plus 3 equals plus or minus 3i. Going to subtract 3 on each side. So x is going to equal negative 3 plus or minus 3i. And if you like to simplify this one more time, we notice that each of these terms, 3 and negative 3, can both be divided by 3. They have a GCF. So in case you see that, you are more than welcome to take that GCF of a 3 out, which would make this equal to 3 times negative 1 plus or minus I. If you see the GCF, that's fine. We will not mark off points if you do not take off the GCF. But in case you see that it has to be divided out of every term, and then you just write your answer just like we were doing in the last unit when we were factoring. All right, 4 and 5. Same examples, right? Same idea. Completing the square. X squared plus 20x equal or plus 103 equals 0. So minus 103 on each side. X squared plus 20x plus some constant is going to equal negative 103 plus that same constant. Trying to figure out what the bottom of that Punnett square is going to be. I take that middle term, which is 20x, divided by 2, and that's going to be a positive 10x. So my Punnett square then, the numbers on that diagonal, are going to be 10x and 10x. Alright, so kind of drawing that stuff down here. I have my x squared. I already said that that's going to be 10x and 10x. So therefore, I'm going to have x times x gives me x squared, x times a positive 10, x times a positive 10, and 10 times 10 is 100. So I'm going to be adding 100 on each of those lines. Write my perfect square trinomial. So x plus 10 quantity squared is going to equal negative 103 plus 100 is a negative 3. I want to get that x by itself, so I'm going to take the square root. X plus 10 is going to equal a plus or minus 3 times a negative 1. X plus 10 equals plus or minus. There is no square root of 3, but I have to take that I out. So I times the square root of 3. I want to subtract 10 on each side. So x is going to equal negative 10 plus or minus I times the square root of 3. They are not like terms, so that is my final answer. Alright, last example here, I'm completing the square. X squared minus 14x plus 164 equals 0. I'm going to subtract 164 over to the other side. So x squared minus 14x plus some constant is going to equal negative 164 plus that same constant. When I try to find my Punnett square, what goes to complete the square, we have to remember to take that sign of the b value. So that's negative 14x. Right? If I divide that, it's going to be a negative 7. Please do not forget that negative sign. It's going to change our binomial. Not so much the constant, but it's going to change that binomial because it's going to be a negative 7. So negative 7x, negative 7x. Figuring out the outsides, x times x times the negative 7, x times the negative 7, and negative 7 times negative 7 is a positive 49. So I'm going to be adding 49 on each side, writing that perfect square trinomial, x minus 7 squared is going to equal negative 115. Take the square root of both sides. I want to get that x by itself. So x minus 7 equals the square root plus or minus square root of 115 times the negative 1, because I see that negative in there. So x minus 7 is going to equal plus or minus. I'm going to remove that I. And there is no square root of 115. I want to still isolate that x, so I'm going to add 7 on each side. So x is going to equal 7 plus or minus I times the square root of 115. Alright, that is our final answer. That takes us to the end of this video, so go ahead and practice completing the square. Again, those x values are just our solutions. Go ahead and try activity 3B.2.